So the question is, how good are my figures? Are they what we would expect from a 10 watt transmission into a center loaded whip at those sort of distances? When we did the electric field strength measurements, we were careful to take note of the transmitter power going into the 20 metre basically mobile center loaded whip. Now again, referring to Owen Duffy's website, Owen gives an antenna factor for a short tuned vertical whip with a concentrated coil, which is basically what I used. And using his calculator, I came up with a figure for antenna factor given the amount of given the frequency and the termination loss. The termination loss is based on the standing wave ratio that I measured on my SWR bridge between the transmitter and the antenna. In addition to that, Owen also has a calculator that converts antenna factor into gain, and here we have an antenna factor of 7.25 dB meter being equivalent to minus 14 dBi gain. These figures are important if we're going to find out how accurate my measurements were. So we have a reasonably good idea of how much radiation power we're putting out from the center loaded whip, knowing its antenna factor, the frequency, the power of the transmission, etc. Owen has a calculator, a field strength calculator, which comes in very handy. And inputting the figures of a distance of 1 meter and the frequency I'm using and the what I believe to be ultimately the transmitter antenna gain in dBi, we come up with a figure of a field strength power of minus 12.57 dBm. Now, the actual measurement I got was minus 14 dBm. This is at 1 meter. I've done these field strength calculations, or used the field strength calculator for all of the distances. Here's the result for 4 meters. The calculator says minus 24.6 dBm. I measured minus 25 dBm. The calculator at 10 meters gives me a figure of minus 32.57 dBm, and I measured 33. And at 20 meters, the calculator gives me a figure of minus 38.59 dBm, and we measured minus 39 dBm. At 50 meters, the calculator predicts minus 46.55 dBm. We measured minus 48 dBm. Now, one thing to remember is when taking field strength measurements that the orientation of the loop is correct for the direction in which you're pointing. For example, if the loop is at a bit of an angle, then it's not intercepting the electromagnetic field correctly. However, we were reasonably careful to keep the loop as perpendicular as possible to the direction of the radiation. However, there are small variations just due to that effect. Also, remember, these measurements look pretty good. However, they are not certified measurements, so you can't claim these measurements as being gospel. However, before, for example, getting involved with a level 2 compliance and having somebody come in who's qualified to take these measurements, at least by doing it with the power meter yourself, you've got a reasonable idea of how successful you are going to be in proving that your particular setup is safe for and meets the level 2 compliance. If it's way out, if you find your measurements are way out and you're getting very strong electromagnetic fields in areas that shouldn't be there, it's a good idea to know before you call the fella in with his meter and his fee to tell you what you basically already know. You might want to actually change the position of your antenna or do something to get it within what you believe to be the limits. Then you can call in the certified electromagnetic radiation specialist and get his report for your particular compliance requirements. And also remember that even though you may be transmitting less than 100 watts and the mathematical calculators and the web calculators all say that you do comply and that everything's nice and safe. There may be certain circumstances where you've placed a certain antenna or have something where there is a peak of radiation which is maybe a little bit unhealthy, and it's nice to be able to move around your property and around your installation with a power meter and just double check that everything is in fact quite safe. The calculators and mathematics can never tell you or predict all circumstances. There may be a piece of metal somewhere that's resonant and acting as a gain booster to your transmission. For example, if you're using a vertical of some sort, you may find that a pole not far away may be acting as a reflector and increase the signal strength in one particular direction. That direction may happen to be the shack, and you may find yourself getting a little bit warmer than you should be. So it's a good idea to have a reasonable knowledge of the electromagnetic field strength in and around your amateur radio station for your safety and the safety of those around you.